to factor this completely. X to the fourth plus 8x squared plus 7. If you're just joining us, we were having some technical difficulties, so we already had this written down. Alright, so I'm going to ask the same questions. Is this a quadratic polynomial? No. Is it a difference of squares? No. Is it a difference of cubes? Is it a sum of cubes? No. Can I write it factor by grouping? Did I ask if there was a greatest common factor? There's not. Okay. We don't know how to factor a problem like this. Okay. This is a quadratic polynomial that we don't know how to factor. So you're going to use this method when you have a quadratic polynomial that has 4 degrees, 2 degrees, and 0 degrees. 4 degrees, 2 degrees, and 0 degrees. Alright? If it doesn't, you can't use this method. Alright? We call it rewrite the quadratic polynomial as a quadratic. And it's kind of weird, but it works. I don't know why. I didn't make it up, but it works. And I don't know why my mouth does not match my voice or my eyes, because sometimes, I don't know. Sometimes it records weird. I don't know. Anyway, so what you do is you replace x squared with a. Replace x squared with a. Okay? So my first term's not x squared, it's x to the fourth. What do you think I'm going to write? Nice, a squared. Plus, instead of 8x squared, I will write 8a. And my last term doesn't have an x, so I'll just write plus 7. So didn't I rewrite it to make it look like a quadratic polynomial that we know how to factor? How do we factor a quadratic? T-chart divide and slide, right? All right. So a equals 1, b equals 8, and c equals 7. Make our little T-chart. We've done this a million times. I need two numbers that multiply together to give me a times c. A times c is positive 7. Hold on. They need to add to give me b, which is positive 8. I got to get there first. So what do you think? All right. 1 times 7 does give me 7. What's 1 plus 7? 8. Is that going to work? Heck yeah. Positive 1 and positive 7. So go back, make your parentheses. Right now we're using a, so a will be my first term in each set. And then we know we have a plus 1 and a plus 7. Well, but we're not solving these, we're only factoring them. If we were solving, yeah, but we're just factoring, okay? But hold on. Do we need to divide and slide?
No. It's over 1.
Yeah, if it's a is just 1, we can, but is it going to change anything? No, so we don't have to. Now, real quick, are these my factors, a plus 1 and a plus 7? Is my first term times my first term my first term? No, a times a is a squared, not x to the fourth. 1 times 7, 7, true. But I want to factor x to the fourth plus 8x squared plus 7. Currently, we have factored what we changed it into, but we can't leave it like this, okay? So we've completely factored a squared plus 8a plus 7, but these are not our factors of the original problem. Any idea what we do now? Well, yes, and instead of a, we're going to put x back in there. Okay? So once you get to this point, now we will undo what we did, basically. Replace a with x squared. I meant to put parentheses, not, a quotation mark, not a parenthesis. So instead of a plus 1, I will put x squared plus 1. And instead of a plus 7, I will put x squared plus 7. So now is my first term times my first term give me my first term? Yeah, x squared times x squared is x to the 4th. And my last term times my last term, 1 times 7, gives me my last term, right? Factored. You can't do this on any quartic polynomial. Just because it has 4 degrees does not mean you can use this method. It has to have 4 degrees, 2 degrees, 0 degrees. If it goes 4, 3, 2, 1, 0, can't use this method. It's 4 degrees, 2 degrees, 0 degrees. That's the only time you can do it. Yes, sir. What's that?
It won't be because it's like terms will just happen together. Yeah.
Quartic means your highest degree is 4. Yeah. Yeah. Did I misunderstand your question? Okay. So let's try this one. X to the 4th minus x squared minus 2 equals 0. Now, on my classes that have already taken the chapter 6 test, they're like, well, I don't know. When I look at it, I don't know where to start. Like, I don't know what it is. That's why I keep asking you the questions over and over every time, because I want you to ask them in your head. You have to look at it and you have to identify it and know what kind of problem is this and how do I factor that particular problem. Okay? Is it a quadratic? Quadratic.
No.
No. Quadratic we factor using teacher on divided slide, right?
So
Oh, is there a GCF?
Yeah. No. X. No. No, there isn't. There isn't one.
There's no GCF. Can I factor by grouping? No, it's got to have 4 terms before you can do that, right? Is it a difference of squares? Difference of squares is a perfect square minus a perfect square. Only 2 terms, first of all. No. Is it a difference of cubes? No. Is it a sum of cubes?
No.
Is it a quartic polynomial that we can rewrite as a quadratic polynomial? All right. So, wherever we see an x squared, we replace with a. So, instead of x to the 4th, we'll write
wait, my bad. A to the 4.
no,
No.
a squared minus
4a squared. Oh, yeah.
what?
A4.
Children, replace
X squared.
x squared
With a. Oh, okay.
with a. So, x to the 4th, we did not write a to the 4th, we wrote a squared because a squared times a squared, right? We needed 2 of those because they're, right? Like we did. So, instead of minus x squared, we'll put minus a minus 2. And I don't know why I put a 0 because we're not solving, we're just factoring. We usually put equals when we're solving. So now I have a quadratic. Factoring quadratics, I use the t-chart and divide and slide, right? Okay, so I have to define A, B, and C. What is A?
1.
What is B?
-1.
What is C?
-2.
Make your little t-chart short and stout. My handle, here is my spout. I need 2 numbers that multiply together to get A times C. And 1 times -2 is -2. Oh, you already gave me the answer. And add to get B, which is -1. What was it, Jose? Positive 1 times negative 2 is negative 2. What is 1 plus negative 2? Negative 1. Make your parentheses. A will be the first term in each set. T-chart, a positive 1 and a negative 2 is what worked on both sides, right? So we'll put a plus 1 on one side and a minus 2 on the other.
So
Hold on real quick. Do I need to divide or slide? Because A is 1. If it was any other number, then I would have to. Are these my factors? No.
Let me give you the answer.
Right, I got to go back and undo this, right? So now, wherever I saw x squared, I put an A. Well, now where I see an A, I have to put an x squared. So what do I have?
x squared and 1. X squared.
Okay. Now, those are quadratics. I don't think you can factor these, but if I could, what is A in x squared plus 1?
What would you mean?
What's A?
1.
In x squared plus 1, what's A?
A is x. A is x squared.
No.
Just change it to x squared.
I know, honey. If it's a quadratic, I should have said this up here and I didn't. That's probably why I'm confusing you. If you have a quadratic polynomial, you might be able to factor it further using the T-chart and divide and slide, right? If you can, you have to. So up here, if I were trying to factor x squared plus 1 using the T-chart, what would A be? Just for x squared plus 1. 1, what is B?
1.
0, and C is 1. So are there two numbers that multiply to get positive 1, add to get 0?
No.
Negative 1 times negative 1 is positive 1.
Oh,
What's
yeah,
negative
yeah.
1 plus negative 1?
0, yeah.
No. Hold on. Multiply to get positive 1, add to get 0. 1 times 1 is 1. 1 plus 1 is 2. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. Is that going to be factorable? No. Over here, if A is 1, B is 0, C is 7. Two numbers that multiply to get 7, add to get 0. Is that possible? No. So I couldn't factor that any further. If I could, I should have. Down here, A is 1, B is 0, C is 1. Could we factor it in the problem above? No, we just tried, so we can't factor it now. How about x squared minus 2? A is 1, B is 0, C is negative 2. Two numbers that multiply to get negative 2 and add to get 0. Is that possible? No. If it was, we would need to factor further. Okay? So all I'm trying to show you is when you get a quadratic left in your parentheses, you need to double check and make sure you can't factor it any further. Because if you can, then you have to. Otherwise, it's not completely factored. Sometimes when you factored, what if that was x squared minus 4? That would have been a difference of 2 squares, right? Can we factor a difference of 2 squares? Yeah, so we would need to. Do I need to do another one of this type? Any yeses? Raise your hand. Any yes? Okay, let me show you. Again, we're just factoring. Oh, sorry. My big head's in the way. It is cubic polynomial of 4 degrees. Hey, what would my in behavior be? Down and up. I should ask y'all that on the other ones. How many solutions would I have if I were solving it? 3, real and imaginary, real and or imaginary. So that means this could cross the x-axis 3 times, right? It won't necessarily will, but it could. Could it cross more than 3 times? No. However many degrees you have is the maximum number. So is this a quadratic? Nope. So we can't factor by t-chart and divide and slide. Oh, is there a greatest common factor? No. Is it one of those we just talked about where it's a quartic and we can write it as a quadratic? No. Is it a difference of two squares? No. Is it a difference of cubes? No. Is it a sum of cubes? Is it a perfect cube plus a perfect cube? No. Sum of cubes is going to be two terms. One's a perfect cube, the other one's a perfect cube. And there's a plus in the middle, right? When you see four terms, there's no way it could be sum of cubes, or difference of cubes, or difference of squares. What else do I know?
Grouping.
Factor by grouping. Whenever you see four terms, automatically you go to factor by grouping. Now, it doesn't automatically mean it's factorable, but that's the only way we know to factor it at this juncture. Am I right? Okay, so remember, factor by grouping. And the notes that we took in the last class, we had one example of factor by grouping. So if you weren't here, make sure, don't just get the notes. You really need to go and listen to the video. Watch it and take notes from the video. You might even want to take notes first and then just watch the video if you're not getting it, okay? But don't just write them down quickly and expect that you're going to know what to do, because you're not going to. All right, so you group your first two terms together, you group your second two terms together. And you're going to treat it separately, and you're going to factor out the GCF of each group. If the GCF is only 1, then you take out a 1, all right? In my first group, what's the greatest common factor? X squared. So to see what's left after I factor it out, just divide the first two terms by x squared. Right. So x cubed divided by x squared is x. Think about it like this. I had 3 x's. I took out 2, only have 1 left. Or if you go in the opposite direction, what's x squared times x? X cubed. We need to end up with what we started with, right? What's a positive 4x squared divided by a positive x squared? Positive 4. There's no x's. I had 2, I took out 2. No x's, right? Check it by distributing. What's x squared times 4? 4x squared. If we would have put an x there, x squared times 4x is 4x cubed. That's not what we started with. Am I right? Okay. Second group, we're still doing the same thing we were doing last time you were here. It doesn't change. We're getting a lot of practice on this. I know. Okay, second group. What's the greatest common factor? 3. And remember, whatever that sign is of that first term, you have to take that sign. Okay, and we're recording this too, Mr. Brown. See me up there?
That's cool.
I
I
know.
can watch it tonight.
Exactly.
What's the website?
Edmodo.
So I can go to like.
We got to have a code. Yeah. But I also put it on my YouTube, so you can go to my YouTube as well. X plus 4. Okay. Now remember, I told y'all that just because there's 4 terms does not mean it's factorable. To know if it's factorable, you got to get to this point.
Can I ask a question too?
Yes?
Did you just say x plus 4 because it's x plus 4, or because you got x plus 4?
Because a lot of kids do that.
Because like when I used to do it, it won't work once you get x plus 4 twice. So I used to write down x plus 4 twice. Guys, do it twice. Do it twice, because sometimes it won't work. And if it doesn't work, then you're messed up.
Or sometimes you made a mistake in the first one, and you're rewriting it again, and it wasn't right the first time. So if you get something different right here, probably you did something wrong. And if you didn't do something wrong, then it's just not factorable using this method. You can't do it. Okay? But like he's saying, don't just rewrite it because you saw it in the first one.
If that was a 9 instead of a 12, you get x plus 3. You're messed up. You can't do it. Don't just write down that.
Right? Okay. So, is this factorable? Yeah. So, remember, you make two sets of parentheses. And what you're doing is, do you not see that you have a common factor in each of these terms? Okay, so you're just going to factor it out. All right, so I'm going to factor out an x plus 4 from my first term and from my second term. And you know when you factor something out, we usually put it outside the parentheses, but because it's two terms, we're just going to group it in one set of parentheses, okay? And then remember, what's left on the outside, those GCFs that you took out to begin with, just group those together in the other set. The one that we did last class that y'all were like, what? I'm just going to skip this one. Remember, we had a GCF at the beginning. Once we got to this point, it could be one of the factors could be factored further. And I told y'all that that one had everything you would possibly see on a factor by grouping problem, but they're not always like that. So this one wasn't like that. We didn't have all that extra stuff, right? But you do need to double check. What kind of polynomial is this if you base it on degrees? Linear. And to factor a linear polynomial, the only thing you can factor it is if it had a GCF. Somebody said it. GCF. Does it have a GCF? No, so we can't factor that. This is a quadratic, so it might be able to be factored further. Just double check it. Probably can't, but sometimes you're going to get a difference of squares there. If you could, and you could just do this in your head. Y'all know A is 1, B is 0, and C is 3, right? So do we have two numbers that multiply to get 3, add to get 0? There's no B. So we can't factor it, right? Okay. So this is my answer. Do y'all need to see one more of that type before I give you those 12 to do on your own? Tell me now. Yeah. All right. Are we going to need to see any sum of cubes or difference of cubes? The ones we did for homework?
No,
I already know that.
Okay. You want one more of these?
No, not that one. Can you do one that does at the end?
Have to factor further?
Has to factor further.
Because I know how to do the cubic one, I know how to do the quick one, and I know how to do the homework thing, but the rest I don't know how to do. So do something I don't know how to do.
Quick tick.
So do this one, is what you're saying? It's either this one or not.
No, I did it. I know how to do this one right now.
Hold on, let me find.
But do something I don't know how to do.
Well,
What do you know how to do?
I just said what I know how to do. Though.
I don't know what I don't know how to do.
Okay, I know how to do the two things we did here today.
Yeah.
Uh-huh.
Everything.
Really?
You know how to do the T-chart divide and slide.
Yeah.
You know how to do sum of cubes, difference of cubes. That was a homework. You said you know how to do that.
Oh, yeah.
Okay. You know how to do difference of squares.
What's that?
We have a perfect
we have
square
one
minus a
on
perfect
homework
square.
too.
We have one on homework too. And
Do the perfect square rounds.
That's the.
okay, that's the easiest one. Bob will do it for you. I'm trying to find the one that we did that you have to do it again at the end.
Want me to make one up?
That's gonna have to be factored again at the end. Yeah.
Hold on. It'll be factored at the end, so it'll be like a perfect square x minus, and I'll put x plus square, but x cubed minus plus 3x minus. X cubed plus 3x squared minus 4x minus 12.
X cubed plus 3x squared.
Minus 4x minus 12.
Okay. So, is it a quadratic? Can we do a T-chart divide and slide?
No.
Is it a difference of squares?
No.
Difference of cubes.
It's the same thing we
Sum
did
of
here.
cubes. I'm going through the list because I want you to ask yourself so you know how to do it.
But I don't know what any of the other things mean.
Just go with me. Just go with me. Okay,
No,
just go
it's
with
none
me.
of those.
Okay. Was there a greatest common factor?
No.
No. Is it a quartic that I can rewrite as a quadratic? Is it a factor by grouping?
Yeah.
If it's factorable, it's factor by grouping, right? Because there's 4 terms. Okay, so what do I do first? Yeah, group the first group and the second group. Take the GCF out separately. What's the greatest common factor of my first group?
X
X squared.
X plus 3.
Hold up. You so fast.
Wait. Of course you need to write it down. Oh,
So how'd you get X plus 3, Cody?
because
Be
it's
nice.
X squared, and then X cubed divided by X squared is X.
Uh-huh.
And then 3X squared, take away the X squared, it's just
Okay. So we understand that? We just factor out GCF like we've done 1 million times. Is there a GCF in your second group?
yes.
Yeah, okay. Remember also, hold on. When you're doing factor by grouping, you know how normally if your greatest common factor is 1, we don't take out a 1, right? But factor by grouping, you have to, because you're going to end up with 2 parentheses and maybe a GCF on the outside, and you have to have 2 terms in each set of parentheses. So if it's only a 1, you have to take out a 1. What is it?
-4.
-4. Now, did you take out a negative because both of these signs were negative? Okay. You don't. If that was a plus, you would have still taken out a negative. Whatever this leading term is, that sign is the sign you use. Okay. You don't have to just because they were both negative. So if you factor out a -4, forget about that other set. What's -4x divided by -4? X. What's -12 divided by -4? Is this factorable by grouping? How do you know? What's the same?
X in the parentheses.
In the parentheses. So what do we do now?
Take 2 sets of parentheses, X plus 3, and then X squared minus 4.
Do y'all agree with him?
Yeah.
Okay. X plus 3, because that's our common factor. Right? And then we factor it out. What's left, we group together. We have X squared minus 4.
And that's a difference of squares.
Is it a difference of 2 squares?
Yes.
Is this? What about this? Can I factor X plus 3? No, it's linear. Only way you can factor linear is if they're GCF, right? So the linear, don't forget about it. Okay, Jonelle, you said you were confused about the difference of squares? Remember, if it's a perfect square minus a perfect square, you make 2 sets of parentheses. What's your signs? One is signs. Signs. Like a plus. What? One's positive, is that what you're saying? Yeah. Wait, what? Just your sign. Are they both positive? Are they both negative? Is one?
One negative.
Okay. One positive, one negative. Can they both be positive on difference of squares?
No.
Can they both be negative? No. What's going to be your first term in each set?
X.
Because why?
X squared is X.
Correct. What's going to be your second term?
Okay, one's gonna be 1.
They're both going to be 2.
Jonelle, what's the square root of 4? 2.
But they're both
So they're both 2.
Okay, I thought we had to look for the square root of X.
Yeah, it's X.
We did that.
We already did that. X squared. X.
Can I factor anything any further?
No.
Are you sure? This is linear. They're all linear. The only way to factor linear is if they have a GCF. If they don't, then you know you can stop checking to see if anything else is factorable. But just wondering, how many solutions would we have if I wanted to graph it? What's the solution here? -3.
Positive 2.
Wait. What's this one?
-2.
-2. Positive 2. What's our end behavior?
Down.
Down and up. So could we graph this? Yes.
So this was a quadratic. I mean, we keep on going because it's a quadratic.
We kept on going because this was, remember last class we learned all those different types that we could see? And one of them was when you had a perfect square minus a perfect square. You could still do a T-chart and divide and slide on that because it's a quadratic. But if you realize that it's a perfect square minus a perfect square, you can factor it super fast and easy.
But you know, we didn't do that.
I know, because it wasn't a difference of squares.
because you can't. Positive 3 is the square. Positive 3 is the perfect square.
And it's plus sign.
Yeah.
Difference is minus. You have to have a perfect square minus a perfect square. So we got two problems there. You see what I'm saying?
So if it wouldn't have been for that, would have ended right there.
Correct. Yeah, if that would have been x squared even plus 4, we would have stopped.
Okay.
Check out my YouTube.
I love y'all.
No, I just put these on YouTube because the video is too big to upload to Edmodo, so I have to put it on. No, I don't even put like things on there where people would look for it. I just do it so I could get a link to copy to Edmodo because that's the only way. Edmodo won't take a file as large as these are. Do you need to see any others? 12 problems. It's 128. Okay, I am going to post this video if you need to go back and see it again. Okay, or for entertainment purposes. Okay.
I'm making myself